Hi, everyone, and welcome back after your coffee break. There were a few people in the morning that had some technical issues. So just first of all, just to head that off, I think the organizers are just going to post into the either discussion forum or the live Q&A some of the things that helped some of the other people. So I think it's using Chrome and getting rid of their cache and what have you, that worked for a couple of people. So in case you do have any trouble with presentations or the video freezing going forward, I recommend just following those instructions. I'll go now to our first speaker for this mid-morning section, delivering a keynote address on the benefits and risks of digitally enabled modular housing. Professor Konstantinos Stavridis is Professor of Structural Engineering in the Department of Engineering, School of Science and Tech at City University of London, and leads the steel, concrete composite and hybrid structures group. His work on material distribution and design optimization of lightweight structures has led to the publication of over 170 papers. Konstantinos is also director of the research group 3D MBC, which works across industry to address challenges in steel and timber modular construction. Konstantinos, over to you.
Thank you very much, Trina. Thank you very much for the introduction. So hello from me to everyone. I'm Kostas, the shortcut of my name. And today I will give you a presentation on the digitally enabled modular housing in the UK. My presentation, as you can imagine, is a bit more on the research side of things rather than the policy as we've heard this morning. I hope you find it interesting. See it as an extended break on something different to what most of the speakers will be talking about today. So hopefully there will be some key messages that coming out of this. So in the next slide, I'm showing the main topics of this presentation, which is the benefits of standardization in the prefab construction and the capacity for reuse. The role of modular connections in particular, we're focusing a lot on the modular connections, and the digital track and trace of prefabricated structural components. So in the next slide, it's a kind of a common theme. Everybody knows that the modular construction and MMCs is increasing over time. I would like to show that one because it shows a little bit of the global picture. And it has been reported that by 2026, the modular construction market will be increased by about 40%. And that will cover both commercial, hospitality, healthcare, education, and institutions. So pretty much everything that we are discussing today. So next slide, please. In the next slide, you see here, again, an international mapping of where we are in the UK as opposed to the housing demand versus the labor rate. We have to say that the UK is not doing that bad. It's got an increased housing demand, although it's been slowing down the last few months. But it's also have a quite significant supply labor rate, which is quite good, despite the problems with Brexit. So we're not as bad as other countries. However, on the right side of the slide, you can see that the UK is not really doing a lot in terms of the off-site share of housing. So countries like Finland, Sweden, Norway, Japan, Germany, they're doing much better than us. In the next slide, we will see how that corresponds to the research that we are doing. As an academic, I have to talk about research and try to link what is the research versus the outcomes of today's market. So again, you see countries like the United States, Canada, Australia, and China are actually driving research on MMC, and followed by the UK. One may ask that how come countries like the United States that don't have too much of housing, modular housing, and MMC at the moment as we speak, although they're driving the research? And I think the answer is in the next slide, where we can see that Nordic countries, Japan and Germany, they are building a lot using MMCs and modular construction, but they are building mainly low-rise buildings and some mid-rise buildings. Whereas in countries like China, Australia, UK, and the US, where there are many megacities, and the footprint, the plots are quite expensive. We are indeed building high-rise buildings, and that's why the research is yet to come and implement that. So the benefits of modular construction and MMCs in general, we know very well. The most significant of all is the time savings, which is leading to cost savings. And what I have to say as an academic is that we need to fund, to boost for funding more research to be done in order to expedite the transformation of the construction sector. So on a recent mapping that we did, we've looked at the UKRI, the Engineering and Physical Sciences Research Council, and we searched for the word modular, for modular construction. And out of the last 3 decades, these are the only projects that we found, as you see here. So if we remove the first one, which is on modular construction, but for nuclear power plants, stations, something that we're not discussing today, we're focusing mainly on housing. The most significant grant that has been funded was the so-called seismic standardization of school components. You may have heard about that. And this is the only grant where the collaboration between several industries and several industrial partners in order to achieve some new connections for standardized connections for modular buildings. All the other grants are in fact KTPs, knowledge transfer partnerships, between a university and a company. To me, that shows that there is not much collaboration between the industrial partners. Every industrial partner is trying to come up with a new product with the help of a research institution and launch that product. But this is not really helping for the standardization. If you move to the next slide, we'll see an even worse picture. So when we did the same study and we've looked at words such as prefabrication or digital, we get pretty much nothing. All the projects you see here, they don't have a costing, a fund, because they're all PhD projects. So there is nothing in the UK's landscape in terms of prefabrication and research. So in the next slide, though, we'll see the European landscape. And by doing a very quick search, we can see that there are multiple multi-million projects that have been funded in Europe, supporting various companies and research institutions and dealing with modular buildings, with prefab components and systems for MMCs, dealing with connections, with smart housing. So a lot of different projects that have been funded, something that we did not see in the UK's landscape. And then in the next slide, you will see a few more. The only one that the UK has been leading, or was leading actually, because it was completed a few years ago, is the so-called MODCONS, Development of Modular Construction for Sustainable Design, Stability and Seismic Applications. So that is the only source of information that we have for the UK design of modular construction and MMCs. In the next slide, you will see a paradigm project. It's called ELISA. You may have heard of that, which was led by Greece, but there are a lot of partners. There is also a British partner in that. And it is a paradigm for us because it has covered pretty much everything. They have done design of new prefab systems, testing and certification, up to the very high level TRL, meaning that the products have been now launched in the market. So this is the kind of the projects that we should be aiming for in order to have a proper collaboration between the industrial partners and get the products out in the market, and of course lead what we're doing here in the UK. So next slide, please. So here I'm trying to connect the standardization with the reuse. Reuse is something that we haven't heard much this morning, and is something a lot the last 5-6 years in the 3D MBC group, because we do believe that reuse is the future. So it's a much leaner process, much fewer steps, much less energy intensive and cost inexpensive, in fact. So we believe that we can reuse modular components via standardization. So both reuse and standardization must exist at the same time. And together with MMC, we can achieve the ultimate. So again, as an ambassador of research and an advocate we're doing in the academia, I believe that the collaboration is the key word here in order to achieve something significant and lead the market. So the epicenter between MMC, standardization, and reuse is the collaboration between industrial partners, the government, and the institutions, research institutions. So next slide, please. So reuse is something that quite a lot of people, they are a bit afraid of dealing with, but reuse of structural steel in particular is something that we have been doing for many, many years now. There are great projects in the UK, the Steel Construction Institute is dealing with that, but also outside UK. Excellent paradigms like the one I'm showing here, where a couple of buildings were dismantled and you can the stock was stored in different places, and then a new building was built using the reclaimed elements from the previous buildings. So we can do that in the we can use the MMC, and you can do that in the modular construction as well. Next slide, please. So nowadays, we even have much more robust and advanced tools to perform the reuse and perform an optimization while we're using AI. So it's not just taking the components from different structures and put them all together. But in terms of optimization, we can optimize the design, we can optimize the transportation, the demolition processes, the deconstruction, repurposing, production, fabrication, and assembly. So all things that can be put in the same algorithms and we can reuse in the best possible way, minded about the cost implications and the social implications of what we're doing. Next slide, please. So in order to realize that in the modular construction per se, we have come up with a new design philosophy, which is the hybrid modular housing design. And I'm sure that you've heard that quite a lot. What is the critical part of this is to split the building, to separate it in two different structures. One is the permanent host structure and the other is a changeable living structure. So there are components that can be changed all the time, every 5-10 years, whatever the business model is, and there can be other structural components of the host structure that can be changed, will be changed after the end of life of that structural component. So all that is doable. We have done case studies. We have represented that this is something that can be done. And the key focus of all these is the connections. And that is why in our group, we are dealing mainly with the modular connections. So I'm moving on now to the next topic. If you can move on to the next slide. Yes, please. So we realize the complexity of modular systems, and that's why we design connections for transportation, installation, deconstruction, and reuse damage-free. That's the critical part of the story, that we want to be able to reuse structural components without having been damaged. Next slide, please. And these connectors, they should also perform for different types of structures, low-rise, mid-rise, high-rise buildings, as well as for wind forces, seismic forces, and progressive collapse. So we're not dealing only about the interlocking mechanism of the connection, but we are designing high-performance connections. Next slide, please. So in a very recent study that we've done, we've seen that there are more than 60 different, if you click more than 60 different joints that have been presented by different manufacturers, different researchers, and different like theoretical kind of studies. And we see that as a problem for standardization. All these different joints, they're completely different. They're very hard to be used. There are no design guidelines, and they're killing the standardization and the reuse purposes. So what we've done in this study that you can see at the bottom, we characterized all these connections and we classified them for different types of buildings and different types of structures that need to be constructed. So the next slide, if you go to the next slide, please. Yes. So we are, I've been working with my group for the last 5-6 years on optimizing connections for steel, light gauge steel, as well as timber modular structures, as you will see in the next slide. And what we're trying to do is not only to optimize their performance, but as I said before, to look to study the fabrication techniques, to study the installation techniques, as well as the dismantling techniques from different manufacturers, what is happening here in the UK, but as well as in other countries, and kind of standardize those processes in order to help engineers. In the next slide, I think you will also see some proposals that we have made for the installation and deconstruction of volumetric timber modular buildings. The next slide, you see that we are working on many different types of connections, and we're trying to borrow characteristics from flexible and adaptable connections that they are used for the reconfigurable structures in order to be able to have a connection that can be a fit-for-all solution for different manufacturers, different fabricators of modular building systems. And I think the next slide as well, if you move on, please. Yeah, you will see that we're using different materials. We're using functionally graded materials that they have some advanced properties such as negative stiffness elements. We're using shape memory alloys. We're using some advanced properties in order to be able to accommodate the needs of all the different fabricators and make that ultimate solution that can be a fit-for-all solution. Next slide, please. So ultimately, and I'm closing with this slide on the research stuff, what we've been doing is that we are designing new type of connections that can overperform for different types of structures and not only perform as connections, but also they can be used in order to optimize the performance of the structure as well as the material that we use of the structure. So different types of connections and different tuning some properties of those connections that can give us an optimization in terms of the material that we use. And we're building the frameworks and the design guidelines for these practices. So on the next slide, please. Just a little bit about the digital side of things. We have recognized early enough that the construction sector is quite weak in terms of the communication of the sector. And there are some things that we have been using quite a lot in the drones or using the beam or like some structural health monitoring. But there are other emerging technologies such as the RFIDs or the smart sensors haven't been used a lot. So we're trying to introduce those in our studies and see how much things can change in the next few years. So in the next slide, you kind of a proposition of what we have been working on the last few years, which is how we can enhance the circular economy by track and tracing of the structural components, prefab components used in the modular construction using RFID tags, smart sensors, and BIM. So we have sorted out all these different steps of that circular economy in order to realize the full track and trace of the structural components. So the structural components are taken down, but then they're characterized. We test their materials. We're testing their properties. We classify them. We have a physical product which has an RFID on it with some data, and a digital product on BIM, which the two of them are communicated. And in this way, we can then exploit all the properties of those elements. So in the next slide, you will see that we've built a kind of a classification protocol with different levels of information that need to be stored in these physical and digital, the so-called phygital products. And these information are static as well as dynamic. The static information is information that we store in the phygital twin every single time that we have, we take some measurements, whereas the dynamic information is the one that is changed by itself over time. So by having some sort of like structural health monitoring techniques and recording information over time. So this information, this classified information and the typologies that we build will help us better utilize the phygital product and then enable the reuse of the components. So in the next slides, in fact, there are just a few very quick slides where I will show what we're doing in this 3D MBC product. So if you go to the next slide, please. Yeah, so this is the 3D MBC group, which is split in 3 different themes: the digital design and engineering for DFMA, the novel material systems and testing and certification, as well as the construction automation and offsite manufacturing. So we're covering pretty much everything in the 3D MBC group, and we're fostering activity, safer construction, cost-effective and energy-efficient solutions, increased quality with more affordable. Of course, we're looking at more resilient and lower life cycle costs. And this project or program, better say, is split in 5 different. If you go in the next slide, maybe you can change the slides pretty quickly. Talking about. Yeah, thank you. So advanced, one topic is about the advanced building systems and assembly techniques. Second topic is on the next slide. Sorry about that, it takes a bit of time to change for me as well. So it's a high performance materials for modular systems, and you can see that we're dealing with all sorts of materials, lightweight steel, timber, concrete, and other materials. In the next slide, you will see that we're working on the design for manufacturing and assembly, and we are dealing with different techniques for mainly timber modular construction. In the next slide, we are dealing with design testing and system optimization, and we've been testing numerous types of connections from the micro to meso and macro scale. And finally, in the next slide, is the projects that we're working on, the applications of on-site construction monitoring, as I said before, for gathering, collecting all that information and updating the physical and digital models through the RFID tags and the BIM. So in the very final slide of the presentation, I would like to synopsize the benefits and risks of MMC, at least from my perspective, research perspective. So we believe that sustainability can be achieved through enabling reuse in modular construction. There are a lot of technologies such as RFID tags, smart sensors, autonomous construction for repair and removal, BIM, and virtual reality that can offer safety, accuracy, and increased production. And advanced and highly optimized materials for structural projects can set the UK being competitive in the international market. Now, the risks are starting with not getting involved early enough. So other companies from the outside the UK, they are leading the market. That is one of the biggest risks for me. And the second one, which is the unfair company competition. If we avoid collaboration, as we have seen so far from the research side of things, which can create complexity to engineers and expense to users. And the final one of the key risks is the non-flexibility, better say, to changing business models, such as the leasing structural products business model. So that's it from me. I hope that you have taken some key points out of this presentation. I know that is a bit boring when it comes to research, but there are a lot of things that have been done in the recent years. Thank you.
Thank you so much, Konstantinos. I don't think it was boring at all. I mean, I was particularly struck by the components and how a seemingly small thing like the connections